Okay, so in this video, we're going to plot a couple more types of polar curves, a little bit more advanced polar curves. So the first of these is going to be a rose. So what I'm going to do is I'm going to first draw it and then I'll justify it. Okay, something I want you to do is I want you to pay attention to the order in which I'm drawing this curve, if I can do it correctly. Make that a fat point there. Okay, so what's going on here with this curve? Okay, so we're going to start at theta equals 0. So if theta equals 0, cosine 0 is 1. Okay, so then as theta increases, cosine of that angle is going to decrease until theta gets to pi over 4, because then we take 2 times pi over 4 and we get 0. Cosine of pi over 2 is 0. So at cosine pi over 2 we get 0, so we're at the origin. Then cosine is going to become negative as theta increases. It's going to keep decreasing or becoming more negative until we get to theta equals pi over 2, in which case then 2 theta is pi. So cosine of pi is -1, and we're down here. And then we're just going to continue on in the same sort of fashion until we close the loop. Okay, and it's important to note here that this has period 2 pi. Whereas the circles we looked at with r equals cosine pi, or r equals cosine theta has period pi. Okay, so in general, so if we have r equals cosine an even multiple of pi, or r equals sine 2n theta, this is a rose with 4n petals. Okay, because we saw here we had theta equaling 2, and we have 1, 2, 3, 4 petals. Okay. However, and here we have period pi, or period 2 pi. If we have an odd multiple of theta instead, like this, we have a rose with 2m plus 1 petals. And this has period pi. So it's going to repeat itself every pi, like we saw with the r equals sine theta, r equals, or yeah, r equals sine theta, r equals cosine theta graphs. Okay, so for example, r equals sine 3 theta is going to look like this. Again, pay attention to the order in which I'm drawing these. Okay, r equals 3 sine theta should look something like this. Okay, and then we see we get 1, 2, 3 petals. Okay, but we've only gone pi, and you can take a minute or two and think about what it, we end up coming back and retracing this between pi and 2 pi. Okay, so the other type of graph I want to talk about in this video is called the cardioid. Okay, so cardioids are curves of more or less the following shape. So r equals 1 plus sine theta. So you could have 1 plus cosine theta, 1 minus sine theta, 1 minus cosine theta as well. Okay, all of those are cardioids. They just face different ways. Okay, so again, let me draw this down here. Okay, so we start when theta equals 0 at 1. Okay, so we should be distance 1 away. And then as theta increases, our r value should be increasing as well until we get to pi over 2. Okay, so theta equals pi over 2. Okay, then it's going to decrease in more or less a mirror fashion until we get down to pi. And we end up with something that looks like this. Okay, so this is a picture of the cardioid. Okay, again, it's easier to justify it once you've seen it rather than to come up with it on your own. So every graph I'm going to ask you to think about without a calculator or without Wolfram Alpha or something like that, like on a lab or on the homework, web work, are going to be one of these. Okay, so these are a set of the basic sets of curves we can have in polar form. Thank you for watching.